Okay, folks, let me see. I'm going to scoot up here. There we go. Properties of rational numbers, section 11.1. This first example says replace the blank with less than, equal to, or greater than to make a true statement. Now, guys, normally you know that when we're working with fractions, okay, when we want to add them or subtract them or multiply and divide them, okay, when we're working with numbers, it's easier to work with fractions most of the time than it is to deal with repeating decimals. Fractions are accurate and they're easier to work with. But if I'm just comparing these two numbers, I really like looking at them as decimals, okay? So I've got my calculator, you've got your calculator. This first one, I'm going to change it to a decimal. That's negative 214 divided by 14, okay? So that's going to give me negative 15.28571429, question mark. Now I'm going to change the other one to a decimal. Remember, I don't have to add or subtract this with anything, okay? So I don't have to worry about these repeating decimals. I'm just comparing them, okay? Well, I don't even need my calculator for this one. It's going to be negative 15.66666666. Now, remember, I know that the one on the right looks bigger because it's 15.6, whereas this one's 15.2. But remember, they're both negative. So if I were to put them on the number line, right, the one farthest away from 0 is this one. This one's negative 15.6 repeating. This one's negative 15.2857, blah, blah, blah. Okay? So the biggest number is actually the one that's on the left. So in this spot, we're going to put that. Okay? Does that make sense? I know you can't answer me, but there you go. It does make sense. Okay, let's look at the next one. All right? Same thing here. Let's change these things to decimals. That's the easiest way to compare them. If I had to do something, if I had to put them together or multiply them and all that, it's much easier dealing with fractions. But just since I'm comparing them, okay, I'm going to put some spots here for them. We'll change them to decimals and compare them from there, okay? So the first one's negative 3/7. 3 divided by 7. All right, so this one's going to be negative 0.42857. And we'll leave it there. That's probably enough for us to tell. Okay, 5 divided by 6. This is going to be negative 0.83 repeating. Okay, this is, I don't even need to do that on the calculator. That's negative 0.6. Okay, and I don't need to do this one on the calculator either because I know that anything over 9 is repeating. So that's negative 0.7 repeating. All right, now it says from least to greatest. So the smallest thing I've got, the smallest thing that I have is actually the one with the biggest numbers because these are all negatives. Okay, so negative 5/6. Remember, I have to give them the answer back in the form that they gave it to me. Okay, so this was the 5/6. All right, so that's the one farthest from 0. Done with that. Then it's going to be negative 7/9. Okay, then it's going to be, well, let's see, negative 3/5, right? Because that one is negative 6. So now I'm done with those. And then the last one, the biggest one, is negative 3/7. Don't forget about the negatives. All right? Nice. Good job. Good job. Remember, for those of you who have just freaked out and forgot math for the last 7 years, okay, to change a fraction to a decimal, you divide the top number by the bottom number. So that's going to be 9 into 7. On our calculator, we write 7 divided by 9. Okay? Good. Now, that problem's done. Let's look at the next one. Find the number halfway between the given numbers. Okay. Now we have to work with these fractions. So we are not going to change them to decimals because you can already see that's going to be a repeating decimal. And I don't want to mess with that. Okay? Halfway between them. Okay? Well, let's change this one first to an improper fraction. That's going to be 5 times 5 is 25 and 1 is 26. So negative 26 over 5. 3 times 8 is 24 and 2 is 26 over 3. Now let's get a common denominator. okay? The common denominator is going to be 15. I multiplied that times 3, so I multiplied that times 3. 60, 78, negative 78, okay? And then this one here, 3 times 5, so 26 times 5. 26 times 5, that's 130. Now, they want us to find the number that's halfway between these two. Okay? Now, I'm just going to draw a number line here just to give you an idea of what we're talking about. Okay? Got this number, negative 78 over 15. You got this number, 130 over 15. Okay? And they want us to tell them what is the number that's halfway between them. It's something over 15. Right? Okay? Now, here's what I want to do. I want to take the two numerators, right, because they're all over 15, so I'm just dealing with the numerators. I want to get the two numerators, and I want to find the difference between them, the distance between them, okay? So, I do 130 minus negative 78. Because remember, if I'm looking for distance, I just subtract numbers, okay? That means that that turns into a positive, and the distance between these two is 208. Okay? Now that's the distance. The distance from here to here is 208 fifteenths. The distance. Now half of the distance, okay, well that's only 104 fifteenths. Okay? So this distance is 104 fifteenths. Now, I can either add that to negative 78 or I can subtract it from 130. It looks like it's easier to subtract 104 from 130, right? So 130 over 15 minus 104 over 15 gives me 26 over 15. That's my answer. Reduced, right? There's 2 and 13 go into 26, but neither of those go into 15. Okay? Does that make sense? I find out the distance between these two. Then I half it. That tells me the distance from here to here, or here to here, right? And then I can either subtract it from the big one or add it to the small one to find out what's in the middle. Good. Good. Let's keep rolling. No reason to stop. All right? State whether each fraction increases or decreases in value as x takes on its values in increasing order. Okay? So, x is the set of these four numbers. All right? It doesn't have y, but let's just make it y. Let's say that y is equal to this fraction. Tell us what we get. Does it increase as the x increases, or does it decrease as the x increases? Okay? 0, 1, 2, 3. Just plug them in. All right. So y is equal to 14 over 12 minus 3 times 0. Y is equal to 14 over 12 minus 0. Y is equal to 14 over 12. Y is equal to 7 over 6. 7 over 6. Okay. Let's plug in 1. Y is equal to 14 over 12 minus 3 times 1. Y is equal to 14 over 12 minus 3. Y is equal to 14 over 9. And when I deal with that, that's going to give me, oh, I can't reduce that. Okay, 14 ninths. Okay, so far, these fractions are pretty close. What do you think? Do you think this one's bigger or this one's bigger? Okay, I think that one's bigger. This is 1 and a 6th. This one's 1 and 5 ninths. Okay, it looks like it's getting bigger each time because I am decreasing the size of the denominator. If I make the denominator smaller than the numerator, the value of the fraction gets bigger. Think about this. Each time you make the denominator smaller, the whole thing gets bigger. So if I had, let's just say 15 over 15, okay, that's 1. 15 over 10, well, that's 1.5. 15 over 5, I'm making the denominator smaller each time, right? That's 3. 15 over 1, well, that's 15. Each time the denominator gets smaller and the numerator stays the same, the value of the fraction's getting bigger, okay? Remember what we're talking about here. Title of this section is Property of Rational, we could say fractional numbers. Properties of fractional numbers. Here's a property. As the denominator gets smaller, the fraction's value gets bigger, okay? Let's keep going because we're just going to prove it, okay? Next one, y is equal to 14 over 12 minus 3 times 2. Y is equal to 14 over 12 minus 6. Y is equal to 14 over 6. Well, now that's 2 1/3, okay? Which is 7/3. This thing's getting bigger all the time. Now this is 2 1/3. Okay, and let's look at the last one here. Y is equal to 14 over 12 minus 3 times 3. Y is equal to 14 over 12 minus 9. Y is equal to 14 over 3. And what is that? 4 2/3? 14 over 3. So you can see that this thing is getting bigger as the denominator gets smaller. Well, and as those x's get bigger because we're subtracting it from 12. Okay? Good. That's a property we need to keep in our head. As the denominator gets smaller, the value of the fraction gets bigger. Write an expression in simplest form for the number 2/3 of the way from negative 7b over 5 to negative 2b over 3. Okay, well this is the same kind of thing we did earlier, right? Here's our number line. Negative 7b over 5, negative 2b over 3, okay? Now, let's get a common denominator. Negative 7b over 5, negative 2b over 3. The common denominator is 15. Okay, I multiplied that by 3, so negative 21 over b. And then I multiply that by 5, so negative 10b. All right? Now, let's find out the distance between them. Okay? What is this distance? I'm going to change these numbers to the common denominator. It's negative 21b over 15 and negative 10b over 15. So what's that whole distance? Well, it's just the subtraction, right? Let's do this. Negative 10b minus negative 21b, and that's going to turn into a plus, so negative 10b plus 21b gives us 11b. Okay, so this whole distance is 11b over 15. Now they want 2/3 of the distance from here. So that means whatever 2/3 is, right? I want to find out what this number is, because that's 1/3 of the distance. This is 2/3 of the distance, and that's all of the distance. All right. Well, what's 2/3? 2/3 of 11b over 15. Of means multiplying math, I think. Okay. So that's going to give me, I was kidding, 22b over 45. Okay, that's 2/3. I need to add this to that. 2/3 of the way. 2/3 of the way. All right, so I need a common denominator. Common denominator, negative 21b over 15 plus 22b over 45. This is hard. Got to get the common denominator. It's 45, and I'm running out of time. 45, 22b, negative 20. That's going to be times 3 is 63b. Plus 22b is going to give me negative 41b over 45. Negative 41b over 45. Okay? 2/3 of the way. I find out what 2/3 is, and I add it to the smaller one. All right. Great job, guys. I think you're ready. All right?